With its majestic rings slicing through the void like a cosmic crown, Saturn has long captured the imagination of stargazers and scientists alike. But beyond its visual grandeur lies a story far older and deeper than its shimmering appearance suggests. A story rooted in the very birth of our solar system. Saturn isn't just a spectacle in the sky. It's a relic of ancient times. A giant made of gas and mystery that has silently witnessed billions of years pass by. By studying this ringed world, scientists are unlocking secrets about how planets form, how our cosmic neighborhood came to be, and even how Earth found its place among the stars. This journey takes us through Saturn's estimated age, the fascinating process of its formation, the tools and methods scientists use to trace its ancient past, and the profound scientific insights that its age continues to offer. Saturn is believed to be around 4.5 to 4.6 billion years old, making it nearly the same age as Earth and the other major planets in our solar system. This incredible age places Saturn among the original cast of celestial bodies that emerged in the wake of our sun's birth. But how do we know this? Unlike trees, planets don't come with growth rings or labels that say, made in 4.5 billion BC. Instead, scientists rely on indirect clues, like cosmic detectives piecing together an ancient puzzle. One of their key tools lies not on Saturn itself, but in the silent messengers that drift through space, meteorites. These space rocks, especially the ones that date back to the solar system's infancy, carry radioactive isotopes, natural timekeepers that decay at steady rates over eons. By studying these isotopes, especially in primitive meteorites that haven't changed much since they formed, scientists can estimate the age of the solar system and, by extension, Saturn's own timeline. In essence, Saturn was born during the same celestial dawn that gave rise to Earth, Mars, Jupiter, and the rest, each forged from the same swirling cloud of gas and dust that once encircled our newborn sun. Saturn's story begins in the swirling chaos of a young solar system, an era when the sun had just ignited, and a massive disk of gas and dust spun restlessly around it. From this vast protoplanetary disk, Saturn emerged through a process known as core accretion, a cosmic recipe for building giants. Here's how the planet with the golden rings was born. The formation of a solid core. In the frigid outer regions of the disk, tiny particles of ice and dust began colliding, slowly clumping together like snowflakes sticking to one another in the silence of space. Over time, these collisions built a solid core, a rocky and icy heart, several times more massive than Earth. The grabbing of gas. Once this core reached a critical mass, gravity took over. The newborn Saturn began pulling in the light gases, mainly hydrogen and helium, that floated in the surrounding disk. This gas capture happened rapidly, before the solar winds could blow the remaining gas away into space. Refining the layers. In just a few million years, Saturn transformed into a full-fledged gas giant. Deep within it lies the dense core, surrounded by a thick metallic hydrogen layer, a strange, liquid-like state under immense pressure. Above this, Saturn's vast atmosphere formed, composed mostly of hydrogen and helium, swirling and shimmering in bands that still move today. This layered structure is more than just planetary anatomy. It's a fossil of formation, preserving the sequence of events that shaped one of the solar system's most iconic worlds. How do you date a giant? Uncovering Saturn's true age. Unlike Earth, Saturn doesn't have a rocky surface where ancient stones might whisper stories of the past. It's a gas giant, made mostly of hydrogen and helium, with no solid ground to drill into, no ancient crust to sample. So how do scientists determine the age of such an elusive world? They turn to the cosmos for clues. Through a combination of chemistry, physics, and digital simulations, researchers piece together Saturn's timeline with impressive precision. 1. Clues from ancient meteorites. Some of the most valuable evidence doesn't come from Saturn itself, but from meteorites that have fallen to Earth. These space rocks are relics from the solar system's earliest days. Inside them lie radioactive isotopes, natural clocks that tick steadily over billions of years. By analyzing these isotopes, scientists can determine when the solar system began to form. Since Saturn likely emerged around the same time as these meteorites, its age is believed to be roughly the same. 2. Simulating a solar system. To support this, scientists run powerful computer simulations, virtual models of how our solar system came into being. These simulations, which follow the movements of gas, dust, and gravity, suggest that giant planets like Jupiter and Saturn formed quickly, within just 1 to 10 million years after the Sun first lit up. Saturn, then, was among the earliest planets to take shape, a true child of the solar system's dawn. 3. Youthful rings. Ancient planet. While Saturn itself is ancient, not everything around it shares its age. Data from spacecraft such as Cassini reveal that Saturn's iconic rings may be much younger, perhaps only a few 100 million years old. Some of its moons might also be relatively recent additions. This dynamic suggests that while the planet is a relic of the deep past, its surroundings are still evolving, offering a living window into both ancient formation and ongoing change. Understanding how old Saturn is doesn't just satisfy cosmic curiosity, it opens doors to deeper scientific truths that ripple across astronomy, planetary science, and even the search for life beyond our solar system. Reconstructing the solar system's early days. Saturn plays a key role in helping scientists rewind the clock on the solar system. Its massive presence, alongside Jupiter, was central in the great planetary migration that shaped the orbits of today's planets. As these gas giants shifted positions, their gravity scattered asteroids and comets, influencing the architecture of the entire solar system. Knowing when Saturn formed helps pinpoint when and how those dramatic changes occurred. A blueprint for distant worlds. Beyond our Sun, astronomers have discovered countless gas giants orbiting distant stars, known as exoplanets. Saturn serves as a familiar benchmark. By comparing its age, structure, and behavior with those of alien worlds, scientists gain insight into how planetary systems form and evolve throughout the galaxy. In many ways, Saturn is the yardstick by which other giants are measured. A guardian of orbital harmony. With its immense mass, Saturn doesn't just float quietly through space, it actively influences its neighborhood. Its gravitational pull helps stabilize the orbits of other planets and shapes the dynamics of the asteroid belt. Studying Saturn's age and orbital history is key to understanding the long-term stability of the solar system itself. Clues from atmosphere and magnetism. Saturn's swirling clouds and vast magnetic field aren't just mesmerizing, they're full of secrets. The age of the planet provides a timeline for how its complex atmosphere and magnetic field have evolved. Scientists are still trying to unlock the mystery of Saturn's internal heat source, an enigma that may be linked to slow changes unfolding over billions of years. Saturn is far more than a dazzling jewel in the night sky. It is a silent witness to the grand history of our solar system, stretching back more than 4.5 billion years. By unraveling the story of its formation and the scientific methods used to determine its age, we gain a rare glimpse into the early chapters of our cosmic origin. But Saturn's tale doesn't end there. Its ancient presence links us not only to the dawn of our own solar system, but also to the wider universe. As we compare it with gas giants orbiting distant stars, Saturn becomes a bridge between our world and the countless others scattered across the galaxy. In this way, studying Saturn's age isn't just about marking time. It's about understanding who we are, where we come from, and how we fit into the vast and ever-evolving universe.